Hi everyone, welcome to the Bioinformatics Coach channel. In this video, I am going to show you how to merge VCF files using Bcftools. What you should also notice that I have tutorials that show how to install Bcftools in Linux. So make sure to check the description box. You'll find links to videos that show you how to install Bcftools. That is the only requirements we are going to need in this exercise, in addition to you having a Linux system. All right. Now, before we go any further, let me also say that the commands for this tutorial are available in a document. So for those who want a document, there's a download link in the description that you can use to get this document, which has the commands for this tutorial. So take note of that. Let's get back to the slides. So for this tutorial, what we are going to do is to look at 3 scenarios. All right. So if you are going to merge VCF files, then chances are you are going to encounter one of these scenarios. Okay, so we are going to take a look at these scenarios one by one, and I'll show you how to merge the associated VCF files. So let's look at the first scenario that you are likely to encounter when you want to merge VCF files. So in this scenario here, what we are going to look at is to combine or merge VCF files from the same set of samples. All right, so you can have a situation whereby you have 2 files. One is a file which contains SNPs, the other contains indels, like what we have here, snps.vcf and indels.vcf. So there's a way to do this, and I'm going to show you how to do that in Linux using Bcftools. So first of all, let's get to the terminal first, and then let's set up our system. So I'll go to my terminal. So I also suggest you do same. Nice. Okay. So that's what we are going to start with. So first of all, we are going to open our terminal, which we have done, and we are going to cd to our home directory. Then we are going to create a directory, a working directory. This is where we are going to work in. So I will say make dir, and I will say merge snips indels, because that is what we are going to do. Then I'm going to cd into that directory. Nice. Now what we need to do next is to get the example data. So I have the data available. Let's check it. The data is available on one of my GitHub repos. Let's check it out. All right, so there's the repo. The link to this page is in the description box. I repeat, the link to this page is in the description box. So when you are here, what we are going to do is to get this file, snips indels.zip. This file is what we are going to get. So I want you to click it, this snips underscore indels.zip. So click it. So when you click it, you are going to see this coming up. Now I want you to come to the right side and look at raw, this side here. So we want the download link, we will download on the terminal. So right click and then go to copy link. I repeat, on this raw button here, right click and then go to copy link. Alternatively, you can click on this download button here, that's fine, but we are using the link. So what we have to do next is to now go to the terminal, and then we are going to download the file. So that's the file has the inputs. So I'll say wget, and I'm going to paste my link there, the link that I copied. So this is it. So I'll execute this command to get the file. It's a small file, so it's not going to take much time. Now it's done. So if I do an ls, I should see snips underscore indels. This is what I should see. I will clear the screen. I'll do an ls again to see it. All right. Now what I'm going to do next is to unzip this file, i.e. extract the contents. So I'll say unzip, and I'll say snips indels.zip. When I execute it, I'm going to see this text coming up. So now if I do an ls, I should see a directory called snips underscore indels. I'll ls into it. And when I ls into it, I'm going to find these 2 files. So we are going to merge these 2 files. All right, that's what we are going to do here. Okay, Now, let's do this. First of all, we need to index these files. We are using Bcftools, so we need to index these files. All right. So to index the files with Bcftools, of course, what we need to do is to do this, is to say Bcftools and an index. So we are going to index them one by one. So I'll say Bcftools index, and I'll specify the first one, which is here indels.vcf.gz. So I'll say snips underscore indels slash indels.vcf.gz. So I'm going to index it. It's done. If I do an ls into the directory, I'll see a new file which ends with .csi. That's the index file. Now let's do for snips. So I'll say bcftools index. I'll specify the directory slash snips.vcf.gz. Let's execute this command. So once we do that, if I do ls into the directory, I will see another .csi file. These are the indexes. So we need this before we proceed. Perfect. Well done. Now we are ready for action. We are now ready to merge the VCF files. We now have all the necessary inputs. Okay. So for the merging, we will need this command. We will use Bcftools concat. All right. So let's get to the Bcftools manual. So we are going to use this command here, Bcftools concat, this one here. So this one is used to concatenate VCF or BCF files from the same set of samples. Okay, so that is the caveat. Let's just open this. When you open it, you'll get more information. All right, so it gives you more information as to how to use this particular command. So that's what we have here. But I'm going to explain the necessary stuff for you. So just take note of that. All right. Now, there's something you also need to note. It's this help page here also gives some information about the input files. It says the input files must be sorted by chromosome and position. Okay, so you need to make sure that you have sorted them as such. All right, so it's always important to do the sorting. So the files must be given in the correct order to produce sorted VCF. Okay, on output unless the -a is specified. That is to allow for overlaps. So don't worry, I'm going to show you everything so that you don't get confused, so that you can actually do it smoothly as we move along. So take note of that. Okay, so we are now going to proceed. So take note that for the files we are using, I've already sorted them by chromosome and position. All right, so we will move straight to the merging. There's something we are also going to add. We will add -a, and then we are going to add -d. All right, so these are important because we are merging snips and indels. So from the documentation I checked online, I had to add those options. Anyway, let's get to the terminal and I will show you how to do this. All right, so let's get to the terminal now. So I am back to the terminal. We are going to proceed. So to merge snips and indels is straightforward. So I'm going to show you one approach. Okay, so that's what we are going to do. So there's one of the approaches to merge. What you say is Bcftools concat. Okay, that's the command we are going to use, the concat command. That's what we are using. All right, so we will say Bcftools concat and we are adding -d both. Okay, the -d is needed, okay, both because we are merging snips and indels. All right, so we also want to make sure the tool takes care of duplicates. All right, so that's what we are doing that. Okay, so let's proceed. Now, in case you want further explanation also, you can always book a session with me and we can go through them. All right, so If you try this on your own data set and you have a challenge, don't hesitate to book a session so that we can work on it together. All right. So let's get back to the terminal and then proceed. So we have this, okay, for duplicate removal. All right. So let's proceed. We're also going to add -a to allow for overlaps. All right. So that's what we are going to add. Okay. Now we need to merge. So with the merging, if you are dealing with multiple files, like in our case, of course, there are ways to go about it. So I'm only going to show you one approach, but I have a separate tutorial on Bcftools concat that gives different approaches, okay, for merging. Okay, different Bcftools concat approaches for merging. In this tutorial, I'm only showing you one, but then if you want all those other approaches, I have 3 of them, then you can check that video, which has been made exclusively for Bcftools concats. All right. So -a allows for overlaps. Let's just confirm it here first. We need that information. So -a allow overlaps. We see that here. Okay, so in this case, it works. And in any way, once we are done, we are going to validate. We are going to check to make sure that we have the right information after merging. So don't worry. Once we finish, we will look at that as well. Okay, now we need to specify the inputs. So here I'm going to specify all the VCF files in this directory. I'm interested in all of them. So I will just say snips_indels/star.vcf.gz. So in this case, if you also have specific files, then you can specify them one by one, or you can also put them in a text file. I repeat, all these other approaches for using Bcftools concat, I've covered all of them in detail in another video, so you can look at that to look at other ways of using Bcftools concats. Okay, so that's what we have. Then we will add -o z. That's the outputs. Okay, the output format. We want it compressed, and I'll say -o, and I'll add the output file name. So here I'll say snips_indels.vcf.gz. This is going to be the output name, the merge name. All right. So I'm saying snips_indels so that whoever looks at this file knows that this file contains both snips and indels. So ideally, whatever name you use should be descriptive so that it also helps you in the long run. Okay. So this is going to be the final command. So let's execute this command. Perfect. Now it has been done. We have merged both. So when we do an ls, we are going to find the merge file here. Okay, so the merge file is this one, snips_indels.vcf. Okay, so we need that information. Okay, so now we have this, so we can validate. So to validate, what we are actually trying to do is to find out if we have the right information here. That's what we are looking to find. So one way to do this is to check the number of variants in each of these files and also check that same number of variants in this file to make sure that you have the same information in there. So here I'm going to test. Okay, I'm going to start with the indels. I'll find out the number of variants in the indels.vcf file and also check to make sure that I have the same number in this file. And we can also do for the snips. So let's start with the index. We are going to validate. All right. So let's clear the screen. Let's do an ls and then let's start the validation. I'll also ls into snips indels directory. Okay. So I'm going to count the number of variants in this one, in the indels.vcf. And I'll check to make sure I have the same number in the merge one. So to count, I will say Bcftools view, and I'll say -c1. So that C1 here means I am counting the true variant. That's what I'm doing here. So that's for the -c1. You can have several variants, but then ideally you may want to find out the true variants. Okay, so that's why I'm using -c1. Then I will say snips indels slash, and I'll say indels.vcf.gz. So this will give me the variance. Now I need to count. So for the counting, I'll do a pipe and I'll say grep -v-c. I'll bring a single quote. I'll bring my caret and hash, and I'll bring another single quote. So here, what I'm doing that I am looking for lines that end with, or line, let me say, I'm looking for lines that begin with hash. These lines are not variants, so we don't need them. So grep-v here is inverse. So that means that this pattern that we are looking for, they should be excluded. Any line that do not meet this criteria is what we want, and we are counting those lines. All right. So in the VCF file, you have lines that begin with hash. Those are not variants. Only the lines that do not begin with this hash character or symbol are the variants. So that's what we are looking at here. So we are counting those lines that do not start with hash. All right, so let's count and get the number. Perfect. So there's the number that we have, 12596. So what we want to do is to make sure that we have the same number in the merged file. So in that case, I'll say Bcftools, and I'll say view-c1 again. And this time, because it's the merged, okay, this one contains both indels and snips. So I will have to specify that I want just the indels. So I'll say -v and I'll say indels. And then I'll specify that file, which is going to be snips indels.vcf.gz. I'll bring my pipe and I'll say grep-v-c. I'll bring my caret and hash again. So you see, we should have the same number. That's what we have here. So this tells us that indeed we have the same information in this file. That's what you need to know. With the Bcftools view, if you don't use the -c1, you may get a different number, which can be deceptive. So ideally, what you want to find out is the true variance. So this -c1 allows you to get that information. So take note of that. Now we can also try for the snips. So I can say Bcftools view-c1. So snips indels slash snips.vcf.gz. I'll do a grep-v-c. Now you know the pattern. We do it like this. We run it, we get the number of snips. Now I'll do that for the combined one. So that will be Bcftools view-c1-v snips. And then I'll now say snips indels.vcf.gz and I'll grep. All right, so I'll grep like this to make sure I have my pattern, and I'll run it. So once I do it, I should also have the same number. So we have 95663, 95663. So this tells us that indeed the merging has been done and we have the right information in there. All right, so this is how we merge VCF files when dealing with snips and indels. All right, so that's how we do it. Now we are going to do this. So now we are going to look at scenario 2. I repeat, we are going to look at scenario 2. In scenario 2, we are going to combine VCF files from the same set of samples. This time, we are looking at a situation whereby the variants are in different chromosomes and each chromosome has its own VCF file, such as this example here. We have chromosome 1.vcf, chromosome 2, chromosome 3. All right. You should take note that it should be the same set of samples. So that means that the samples here in this file 1, file 2, file 3, we should have the same number of samples. It's very, very important. So you need to make sure you have that also satisfied. Okay, so let's proceed. Okay, so let's get back to the terminal and then let's proceed. So I'll clear the screen and then I'll proceed. So I'll first do a CD. Then after doing the CD, I am now going to create a directory, a working directory. All right. So which working directory am I creating? I'll say make dir merge chromosomes. Then I will cd into merged chromosomes. Then I am going to download the example data. So let's go to GitHub and let's go to this page again. Okay. So on this page, what we need is this is a file, chromosome VCFs. That's what we need. So again, the link to this page is in the description box. I repeat, the link to this repo is in the description box. So when you are here, click chromosome vcf.zip. You'll be sent to this page. When you are here, I want you to come to raw, this button here, right click and then go to copy link. So this will copy the download link for you. I repeat, right click the raw button, copy link. You can also click this download button to download, but we are going to do it on the terminal. So we'll move straight to the terminal. Perfect. So now on the terminal, I'll say wget, and I'm going to paste the link there. I'll use this link. So let's execute the command and then let's get it done. Okay, now it's done. If you do an ls, you should see chromosome vcf.zip. Let's clear the screen. Let's ls. And now let's unzip it. So I'll say unzip chromosome vcf.zip. So I'm going to execute this command. All right, so we have extracted the VCF files. All right, so now if I do an ls, I'm going to find a directory called VCFs. If I ls into it, I'm going to find my files. Okay, so let's proceed. So we can now easily do what we want to do. Okay, now I made mention that to be able to do this, the second approach where we are going to do the concat, we also need to make sure that we have the same number of samples, or we should have the same set of samples in this. Okay, so ideally what you want to do is to try this first. You can just try to see the samples you have in each of these VCF files. All right, so let's even do that first before we proceed. We are doing some form of checks. So I'll just say Bcftools query -l, and I'll say vcfs/chi1.vcf.gz. So these are the samples that I have. All right. So ideally we should have the same set of samples in chromosome 2. So I'll just record this command and I'll change chromosome 1 to 2. So we should have the same number of samples, the same set of samples. So you can just check from here. All right, I think these are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about 12 samples. We should have the same set of samples basically. You can also try with chromosome 3 to see. All right, you can also do this. Let's clear the screen. Just record the command and just say pipe wc-l. So this will give you the number of samples, and you can use that to also make some inferences. All right, so basically just make sure that you have the same set of samples in chromosome 1, chromosome 2, and chromosome 3. It's very, very important. Then we can use the Bcftools concat. So now we are ready to do the concatenation. All right, we are ready to use Bcftools command concat. Okay, now let's do this. So that's what we have to do. We need to first index our files. All right, so when I say files, I mean these VCF files. We need to index them, so we'll use Bcftools. So I'll say Bcftools index VCFs. I'll start with chromosome 1. I'll index Bcftools index VCF/chromosome 2. and I'll do for chromosome 3. So Bcftools index VCFs / chromosome 3. I'll index that as well. Take note that with the indexing, if you have several files, maybe hundreds or tens of files, then using this command one by one may not be optimal. There are other ways to deal with multiple sample files. Okay, multiple files. All right, so in those situations, you have to write a script, or you can use SAX to help you do that. But for those who have issues, you can always contact me or book a session and we will look at all these things. All right, so just take note. Some of these things you need to have knowledge in Linux. So I offer courses on Linux for bioinformatics, so those who are interested can also reach out to me. Okay, now let's proceed. So let's do this. We now have our index, so we are ready to roll. Okay, so we will start with the concat. So here too, with the Bcftools concat, there are 3 approaches. I will give one, and all those 3 other approaches, I've covered them in detail in another video, so you can check that video out. The link is in the description box. So let's use one of them. So I'll say Bcftools concat. All right, that's what I'm going to do. And here it's simple. We don't need any other flags. So this is what I am going to do. So I have Bcftools concat. So I'll specify the VCF file. So I'll say VCFs because that is where they are. And I'll say star.vcf.jz because I want to merge all these files. And I'll say -o z because I want the compressed VCF, and I'll say -o, that is output file, and I'll say all underscore chromosomes.vcf.jz. So here I say all chromosomes.vcf. So that means that anyone looking at the file will know that yes, these are all the chromosomes. All right. So we have this and we can execute this command. So once you do that, it will do all these checks and then it will give us the final file. So if I do an ls now, I should see this file, all chromosomes.vcf.gc. All right, that's what we have here. Okay, now once we have this, ideally we may want to index this VCF file. All right, so I'll just say Bcftools index and I'll specify the file, the mesh file. So ideally you should index this because some operations, okay, some tasks, some processing will require you to have the index generated for the VCF file. So just to be safe, we will index everything first. Okay, great. Now it's time to validate. It's time to check to make sure that we have the information we need. So again, what we are going to do is to count the number of variants in the individual chromosome files, VCF files, and make sure we have the same number in the merge one. So I'll do for chromosome 1. So I'll just say Bcftools. I'm going to count the variants in chromosome 1 and make sure I have the same number of variants for chromosome 1 in the merge file. All right, so that's what I'm doing now. So I'll just type Bcftools and I'll say view. I'm interested in the true variant, so I'll say -C1. Now this one is just chromosome 1, so I'll just specify it straight away. So I'll say CHR1. No, it's in VCFs, so we have to specify the full part. So that will be VCFs /chr1.vcf.gz. Then I'll bring my pipe and I'll say grep-vin-c. I bring my single quotes, carets, hash, single quotes. So let's count it. Perfect. We now have 208. So the number of true variants in the chromosome 1 file is 208 or 208. All right. Now we need to get the same number in the merged one. So I'll say Bcftools and I'm going to add the view command. All right. So the view command will be view. And then this time I'll say -C1 again. And here, because we now have several chromosomes in this file, we will need to specify the chromosome of interest. So here it's chromosome 1, which is CHR1. Okay, so I'll just say CHR1, that will come, but I need to add this flag. I'll say dash dash regions, and I'll say CHR1. All right, and I'll specify the VCF from which this information should be extracted. And then I'll bring my pipe grep-vin-c single quote caret hash like this. And I'm going to run this command. So if I do it, I'm going to get 208 as well. That's what you need to take note of. Now, with the chromosome, I said CHR1. All right, this is because in the VCF file, I know that my chromosomes, these are the names. All right, but if you are not sure of the chromosome names, then you can check yourself. Okay, you can just see Bcftools, query-f, bring a single quote, percentage, and say chrome /n, another single quotes, and specify the VCF file. All right, let's say all chromosomes, or you can use any of the VCF files, any of them, that's fine. And then you can just execute it. So that will let you know the chromosomes you have. Okay, so here I have all these. Now let's clear the screen. I'll modify this command. I'll add sort, and I'll say unique, so that all duplicates are removed. So now we will see that we have this. We have just 3 chromosomes, and these are their respective names. So if you know this, then you can now use whatever you see here in the chromosome label. Okay, it's likely maybe some of your VCF files will have, let's say, 1, or maybe some of you too, if you're dealing with some organisms, you may have, let's say, PF, 3D, 7, etc. So there will be different names. So you need to check using the command I showed, and then you'll be able to put in the appropriate label for your chromosomes. Okay, so that's very, very important. Okay, so that is it for this one. Okay, so you can try and validate for chromosome 2 and 3. Actually, let's do for 2 and 3. All right, so for 2 and 3, I've already done the command. So all I have to do is to just change this to 2 to run it. This is its 2332. So 2332. And I'll do the same for the merge one. So here to chromosome 2. So when I run it, I should get the same number. All right. So now that we've done these two, what I want you to do is to try and do for chromosome 3, and then send me your answers via the chat, via the message section, and then let's discuss it. Okay, that's going to be fun. All right. So that is it for scenario 2, whereby we combine VCFs from the same set of samples, i.e. chromosome 1, chromosome 2, chromosome 3, etc. VCFs. So in other words, we are looking at VCF files with the same set of samples, but then we have them splitted as chromosomes, and we are merging all of them, and that is what we have done here. So let's proceed. All right. So now we are going to look at scenario 3, okay, of merging or combining VCF files using Bcftools. So in this scenario, we are going to combine VCF files from non-overlapping samples, i.e. situations whereby we have, let's say, variant for sample 1 in one VCF file, variant for sample 2 in another VCF file, variant for sample 3 in another VCF file. Okay, so this can happen when you run variant calling, okay, sample by sample. So in that case, that means variant for one sample will be generated, another sample will be generated, and all these will be in separate files. So in some kinds of analysis, it's required to have all your samples in one single VCF file. So that means you need to have a multi-sample VCF file. So I'm going to show you how to combine these and get your multi-sample VCF file. Again, instructions for installing Bcftools can be found in the description box. So let's get back to the terminal, and then let's do a cd to get to our home directory. Okay, I'll even clear the screen first and I'll do it. So I'll just do cd, and then I'm going to create a working directory. All right, there's another project, so we need to get a working directory for it. So I'll just say mkdir, and I'll say merge underscore sample VCFs. I'll cd into it. Perfect. Now I'm going to get the example data. So let's get back to GitHub. So we will get to GitHub. Let's go to that page first. So this is the page that you get the example data. The link to this repo is in the description box. I repeat, the link to this repo is in the description box. So when you are here, I want you to get this file, samplevcfs.zip. That's what we need. So click it, and when you click it, you'll be sent to this page. Come to this side, come to the raw button, this one here, right click, and then go to copy link, and then copy the link. So right click the raw button, copy the link. Alternatively, you can click this button to download. Anyway, we will do it on a terminal once we have the link. So let's go to the terminal, and then let's get our data. So I'll say wget, and I'll supply it with the link to the file. So there's the link. So I'll execute the command to download. It shouldn't take much time. It's a small file. It's done. So if I do an ls, I'm going to see this here. Now let's clear the screen. Let's do an ls, and then let's unzip this file. So I'll say unzip, and I'll say samplevcfs.zip. So when I execute the command, I'm going to see this coming up. So now if I do an ls, I'll see a directory called samplevcfs. So ls into samplevcfs, and we're going to find your files. So here we have sample1, sample2, sample3. Good job. Now we can proceed. Now what we are going to do next is to index these files. It's always important to index. So I'll index them. So I'll say bcftools, and I'll say samplevcf/s001. Okay, that's how it is. But then we have omitted a command, so I'm going to just repeat it again so that we can all do it. Okay, so what we are going to do is to index the VCF files. All right, so we are using Bcftools. So to index, I'll say Bcftools, and I'll say index, and I'll specify the file I want to index. So I'm starting with sample1, so I'll say samplevcfs/s001.vcf.gz. So I'll execute the scripts. I'll do for2. And by the way, when you index, nothing will show. So that means everything is okay. Now let's index for sample2. So that'll be Bcftools index samplevcfs/s002. Let's index this, and let's do for sample3. So the same Bcftools index samplevcfs/s003. Perfect. Now, if the indexing has been done, when you do an ls into the directory, that's a sample VCFs, we are going to find this also there. In addition to the VCF files, you will find files that have the extension .csi. These are the index files. Okay. Take note that with indexing, if you have several files, let's say tens, hundreds of VCF files, then entering the commands one by one will not be appropriate. So there are ways to do this. You can use the xarg utility, or you can write your own script that will take each of these files and then it will process them for you. Okay, so there are ways to go about it. That means you need to have knowledge in Linux. All right, so it's important. For those who want tutorials on Linux, you can also contact me. I organize one-on-one Linux tutorials as well. So you can contact me and then we can look at how to go about it. All right, so just take note of that. Alternatively, you can also use workflow managers like Nextflow snake make. I have tutorials on them as well, so just let me know if you have any challenge. Okay, now let's proceed. We have our index files, so we can proceed. Now we are merging these files, the 3 files. All right, so to merge VCF files, okay, from non-overlapping samples like this, we need this command. Let's go to the web browser. So we need the Bcftools merge command, which is here, this one here. Let's open it here. Okay, and by the way, the link to this page is in the description box, the Bcftools manual page. All right, so here it tells you what you can use this command for. Okay, so you need to also check it out. All right, so you can merge basically. So a VCF file, non-overlapping, that means that each file should contain samples which should be or which should not be present in another VCF file. All right, so ideally that's what you should try to do. Okay, so now we can proceed. We will use a sample command here, but then there are variations depending on your case. Okay, so if some of these things you are having issues, just let me know. We can find out what your situation is and then we can work it out. Okay, now let's get back to the terminal. Nice. So we are going to now merge. So to merge, we will use Bcftools merge. All right, so what I need to do is to say Bcftools merge, and I will specify the files I want to merge. In this case, I am merging all the files. So I'll say sample vcf/star.vcf.gz. Again, there are about 3 different approaches to specify input files when using Bcftools merge. All right, so I have a separate tutorial on Bcftools merge that give all these approaches. In this tutorial, I'm giving just one approach. There are others as well, so take notes. Okay, so here I have this, and I'll say -oz, meaning I want a compressed file as my output, and I'll say -o, and I'll say all_samples.vcf.gz. This is going to be the output file. So now let's execute this command. Perfect, it has been done. So now if I do an ls, I'm going to find the file all_samples.vcf.gz. all right, so this is the merge file which has the information we need. So we are going to do some validation. Okay, so we are going to start by looking at the samples, all right, whether we have all the files in there. So I'll say Bcftools query, and I'll say -l, and I'll specify the merge file. So if I run this, I should see my 3 samples, which are these ones. So that's what I should see. Okay, now let's do some further checks. What I want us to do is to check the number of variants for sample 1. And we are also going to count that number of variants in the merge one. That's going to help us. So I'll clear the screen. I'll do an ls. I'll ls also into sample VCF so that we have this file. So we will start with getting the number of variants for sample 1. So I'll say Bcftools view, and I'll say -c1 because I want the true variants. And then I will specify. So I'll say sample vcf/s001.vcf.gz. I'll do a pipe, and I'll say grep -v-c single quotes caret hash single quotes. Now -v here, when using grep, that means that it's the inverse. We are looking for lines that begin with this hash, and we omit them. So what we are looking for ultimately are lines that do not start with the hash. That's what we are doing here, and we are counting. So that's what we have here. So let's execute this command, and we are going to get a number of variants for that sample, which is here. Now let's try to get that same number of variants for that same sample in the merged file, which is all samples.vcf.gz. Okay, we can also do that here. All right, so to do that, let's first index the BCF2. Let's first index the VCF. This may not need indexing, but let's just do it just in case. So I'll just say Bcftools index all sample of VCF.gz. I'll just index it first. Then I'm going to get the number of variants for that sample in the merge one. So I'll say Bcftools view-c1. And here, because this is a multi-sample VCF file and I want information for just this sample, I'll have to say -s and specify the sample name, the name in that VCF, which is S001. Then I can now specify the file. Then I bring my pipe and I'll say grep-bin-c single quotes caret hash single quotes. Now I'll run this command and I should get the same number, and that's what I see here. All right, so we should have the same. Okay, you can also try for sample 2 and sample 3. If it's sample 2, I just have to change this to sample 2. And then in the main one, which has all the samples, when I come here, I'll just make it sample 2. So that should also give us the same number. All right, so once we have this and they are the same, that means that everything is okay. Okay, so this is how we merge VCF files from non-overlapping sets. Okay, so that's what we have here. So this is the approach. And so for those who want the other approaches, just check the description box. There are links in the description box that you can use. You can also merge VCF files using GTK. So those tutorials are also available. I'll link all of them up in the description box. So check the description box for follow-up tutorials as well. So I'll see you in the next session.